Okay, now screen is visible, right?
Yes, sir.
Yes,
Okay.
sir.
So this topic is divided into two main parts, that is green chemistry. This will be like A part, and nano chemistry, that will be the B part. This green chemistry we will see later on, but the most important thing about this topic is the nano chemistry, and that we are going to see in today's lecture. So here this nanochemistry is just introduction part is covered in this chapter for 12th standard. Here, so what the meaning of a nanochemistry is discussed. For example, this clothes, sunglasses that we are wearing, or the computer hard drives, even the cleaning products, which are made up of, or they are having a nanotechnology. For example, these DVDs, CDs, they are having a very small size particle, and that particles or those particles are also known as a nano components or nano here. काय दिसतं तुम्हाला एक्झाम्पल मध्ये this scale is there, nano scale is there, that from 0.1 nanometer, if you see the various example, a nanoparticle is a very small particle that we cannot see from our naked eyes, right? So all these are which comes below this range is a termed as a nanoparticle. Okay, so this tennis ball that we can see, just imagine if the tennis ball is like this, what is the size of these small particles, like including viruses, bacteria, cancer cell. These are even smaller than the nanoparticle. So the nanoparticle comes somewhere here. Okay, so there are two figures which are shown here. Here the scale of nanomaterial is discussed. Okay, so we can see the nanometer scale if we have a certain characterization techniques only. This 5 micrometers, and on the floor we can see through our naked eyes, right? So this is a small, this is a like a millimeter. When we goes to the micrometer, this dust might, it might maybe not knowing that we can see it or not. If this human hair is there, that also cannot be seen if it is in the smallest range. For example, the red blood cells we cannot see through our naked eyes, which is having a its dimension like 2 to 5 micrometer. And when we comes in our human body, the DNA and RNA is like a 2 to 12 nanometer in diameter. So those are very like impossible to see through our naked eyes. And this is whole scale is given. For example, this nano, that is a 1 nanometer, this is a very important relation, that 1 nanometer is equal to or equivalent to 10 raised to minus 9 meters. Okay, so this is the scale is there, and this scale is given in the meter, in the nanometer, in the angstrom, micrometer. So we can play with this, and we can convert all these into the another scale that we are able to write, or we can able to measure, right? So what is this nanoscience? Nanoscience means is the study of a phenomenon of a material at atomic or molecular scale. Okay, so when we comes about this nanoparticle, if let us consider there is a one particle and this is a nanoparticle, so this will be the nanoparticle. So this material in this size is known as an bulk material. Okay, so the bulk material means whatever the chemicals, inorganic chemicals which are present in our college lab, those are comes under this bulk. And when we reduce the size to the nanoscale, the property changes drastically. So the physical properties, chemical properties can be changed, and what are these properties that we are going to see in this chapter. Okay, so what is exactly the definition of this nanotechnology? So the nanotechnology is the design, characterization, production and application of structures, device and system by controlling the shape and the size of at the nanometer scale. So nanotechnology is this technology or the science which can control the shape and size of a nanometer scale particle, that will be termed as a this nanotechnology. But why nano? So why the name is given as a nano? So there is a meaning of this nano word in the Greek is a like a very smaller, or even its actual meaning is a dwarf. So this dwarf means a small. So this nano actually it is a, this dwarf is a little bit more or having a more size, but this nano is having a more lesser size than this dwarf. Okay, so when we convert this, actual nano means if the scale is in between 1 to 100 nanometer, that particles is known as a nanoparticle. And based on this, the our industrialist Ratan Tata, he discovered this car which is having a smaller size than the, when he compared to the other sizes of these cars, that size of this car is smaller. That's why he gave the name as a nano car. Okay, so the nano car is having smallest size. So as compared to this, again, if you compare these particles, the scale of a particle, when the scale is in between 1 to 100 nanometer, that all this particle is known as a nanomaterial. Okay, so it is a nothing but the 1 billionth part of the meter, that is 1 nanometer is equivalent to 10 raised to minus 9 meters. This is the important relation. This type of a question will be there for multiple choice question. Then the material we see around is everything is known as a bulk, like grains which we are eating or the sand particles, all are in the bulk scale. We can convert them into the nano by using certain procedure. Those are also discussed here. Okay, so all these particles, bulk particles, have their own properties. But when we convert them into nanoscale in the range of this 1 to 100 nanometer, they possess a unique properties like optical properties, structural properties, thermal property, catalytic property, magnetic property, as well as electrical property. So all these properties are the need of recent technology and having a so many applications. Okay, so if after 12th, after your BSc, after MSc, if you want to have a job, so there are so many jobs are there in all these industries which deals with the study of such type of properties. Okay, so these properties are changed in the bulk. When we goes into the nano, those are changed in drastic ways. Why that so? So that is also we discussed here. So what is nanomaterial then? So the nanomaterial is a material having a structural component which at least one dimension is in the nanometer scale. So that will be the very clear definition here. If you have an example, the example is given that this dimension 1, 2 and 3 dimensional things are there. So whatever things which we are watching around us are all in a 3-dimensional way, right? So we can see human body is also in 3-dimensional. So there are 3 main dimensions like 0 dimension, then 1 dimension and 2-dimensional things are discussed here with the example. See this diagram, so it will be clear to you. Okay, so generally when we draw in a graph, so these are termed as in 3 dimensions. Let us consider this will be like an x-axis, this will be y-axis, and this will be z-axis. Here there will be origin. Now 3 dimensions are there, right? So what are three 0, 1 and 2 dimension things? Those are discussed with the help of these 3 figures. First of all, we are going to see what is 0 dimension. So 0 dimension means, what is the exact definition? The structure is one in which all the 3 dimensional are in the nanoscale or like a 0. So if we put this particle in the here at this center, okay, so that will be like an here x dimension. So all the nanoparticles are comes under the 0. Particle means this particle means it is in circular way. So that's why it is a nanomaterial with the 0 dimension. Then in the 1 dimension, see again if we label it as an x, it will be the like y and this will be the z. So if 1 dimensional means what? Is the particle in which 2 dimensions are in the nanoscale. Now there are how many dimensions? 3 dimensions. So 2 dimensions are if 0 scale, only 1 dimension is there, so that will be like a 1 dimensional. For example, here see this rod is shown over here. If we take this rod and if you put it on the y-axis, so it has only the growth on the y scale. Okay, so 1 dimension is increasing, but this is the 0, this is also 0. So only 1 dimension is increasing. So that's why this is known as an 1 dimensional thing. So the example is like wires or the tubes, tubes,
Sir,
nanofiber
I'm not
are
able to
the
see the slide.
this is not visible to you.
Yes, sir. Okay.
Is it visible?
Yes, sir.
Okay, so here only one scale is there, so that's why it is known as a 1 dimensional thing, right? And about 2 dimensional now. 2 dimensional means, for example, film, okay, or a piece of a paper. So what is the 2 dimension? 2 dimensional in the structure. 1 dimensional is a 1 dimension is in 0 scale. So we have a sheet. See, this yellow color sheet is there. If you put it here, this scale is increasing, right? On the other hand, this scale is also increasing. But what about this z-axis? It is not increasing, so it will be 0, and that's why this will be termed as an 2 dimensional thing. Okay, so there is a type. I think there is a certain misprinting is there. That should be like this here. Okay, 2 dimensional things. For example, films, layers, or in a coating is known as a 2 dimensional thing. And we know the 3 dimensional thing means let us consider forget about this yellow thing, and all these boxes which are shown here are nothing but the 3 dimensional, right? So this is the, or even if you are watching your hand, if you see your hand, it will be like a 3 dimensional thing. Okay, so there is a definition of this nanotechnology given, that it is the nanochemistry is the, when we look for the definition of chemistry, what is chemistry? Chemistry is the study of the chemical compounds which contains the chemical reactions, chemical structures, right? But nanochemistry means it is a combination of chemistry and nanoscience, okay, which deals with designing and synthesis of material which is in the nanoscale with different size, different shape and composition. This is known as an nanochemistry. So the nanochemistry is used in the study of this very small particles and their applications. So there are so many applications. We will see this application later on in the same topic. So, if you have heard about these materials, zinc oxide, that is a zinc oxide GNO, and TiO2 is an titanium dioxide. So these particles have very much applications, because all these are like eco-friendly, as well as these particles are they can be used in the various application. For example, when you see the tablets which you are taking, then these creams which you are using as an cosmetic products, all these having a zinc oxide and TiO2. Okay, and sometimes when there are bigger buildings are there on the these buildings, when there is a windows are there, so these windows can be made a UV reflectant by using this zinc oxide and TiO2, or this TiO2 particle, zinc oxide particle can absorb this type of reflections or this UV rays inside, and there will be a very less damage of this particular uh, glass as well as the skin can be done. So these are very important. So you may find on the internet there are tremendous amount of applications are present about this titanium dioxide and zinc oxide. Now there so many physical and chemical properties are there, so we are going to see one by one. Now in the characteristic features or properties, these colors, this is the example of a gold nanoparticle. Okay, so if these colors are visible to you, this is color is nothing but an optical property, right? Color comes under the optical property. So if a gold has a nanoparticle, so it will be like a yellowish color, right? So the generally gold is in the dark or shining yellow color. But if you synthesize a gold atom, and if you combine 100 gold atoms together, then that will be seen as a reddish in color. Okay, so this is the gold solution. So gold is in the bulk. When we have 100 particle, then its color is red. And if you have a more number of this type of particles, atoms, then its color going changing. So in the three, all the three, the sample vials is having a gold particles, but these particles are with the different size and different shape, because this will be having a different optical properties. Then the next is an surface area. So this is very important. See, we are having a bigger particle, and when we go to the nano, means we are making it small pieces, right? So when we calculate the surface area, so this shape is known as a cube. So its area can be calculated as an 6 into a meter square. So that will be like this length is there. Okay, so here there is a one particle is there or one shape is there. So that's why we have taken it as 1 meter square. So total will come is in 6 meter square. When we break this cube into these two lines here, then this one length is there, we half that length, and we have to multiply about the number of atoms which are there. Now when we do it 6 into 1 by 2 meter square, we have to multiply with this atom. So there are 4 atoms present in the top and 4 atoms are present at the bottom, so total will be the 8. So if we have seen this multiplication, there will be like a 12 meter square. So it is a slightly increasing. When it comes into the another one division we did, so total there will be like a 27 new atoms generated, and its surface area is increasing. What this indicate? As we are making a small and small particles, we are increasing its surface area. Okay, so the more aperture, more sides are vacant now. See here, if you put a solution, only the solution will go here, here, and all these 6 sides. But here, if you put it, it will go inside this. Therefore, the surface area is more. So this is can be discussed with the help of a size. Next property is the catalytic activity. So you know the catalyst is it will never take a part in the any type of reaction, but it just increases in the rate of reaction, right? So This is the case that nanoparticles are used for the catalytic reactions. For example, platinum and palladium are used for hydrogenation type of reaction. So these reactions are very common, that when there is a double bond is there, that can be converted into single bond. This is one type of an example. Again, we can separate them, we can recycle them, we can use it again. Again, this TiO2 and zinc oxide that we have already seen, those are having various applications. Along with those applications, those are also known as photocatalyst. So photocatalyst is a different field. So it is just a catalytic property shown by this particle in presence of light. Okay. So there are again so many applications are there about the gold. So you can also search them on the internet. Again, there is a one very interesting thing is there. I think I forgot to tell you that here when you come about the when you are talking about the size of this nanoparticles, so nanoparticle size is discussed here. So the nanoparticle, the earth and its dimensions of the earth, right? And if you are eating an apple and you can keep this apple in your hand, right? So the let us imagine there is an apple and earth is there. Okay, so I think this explanation is given somewhere here. Okay, so see, if you draw the size of an earth, so earth will be, if it is a earth and apple is like this. Okay, so what is the relation here? How many times this earth is there? So that type of relation is there with this apple and a nanoparticle. See, nanoparticle is a very small particle. म्हणजे थोडक्यात सांगायचं तर असं की तुम्ही एक सफरचंद घेतला आणि पृथ्वीचा शेप आणि सफरचंदचा शेप जर तुम्ही कम्पेअर केला तर सफरचंदच्या किती पट पृथ्वी आहे हे आपल्याला लगेचच समजेल. तितकंच असंच इमॅजिन करायचंय की जर सफरचंदला जर तुम्ही ऍपल, हे जे सफरचंद आहे याला जर तुम्ही पृथ्वी समजलं तर हा नॅनो पार्टिकल म्हणजे काय, एक ऍपल आहे. इतक्या पट छोटा हा नॅनो पार्टिकल आहे एका सफरचंदच्या कंपॅरिझन मध्ये. ओके, म्हणजे तुम्ही इमॅजिन करू शकता, वी कॅनॉट सी विथ आवर नेकेड आय अँड दॅट्स वाय these are having a very good properties. Okay, so these are all the physical type of properties. Now we have thermal properties, like in this thermal means there is a temperature comes in picture. This temperature is nothing but our main aim is to calculate the melting point of this compound. So there is a very straightforward explanation is there, as if there is a 1000 atoms are there, its temperature is like a 288 Kelvin. But if you increase the number of atoms, its temperature is also increasing and it is going on and on. Okay, so as the temperature or melting point increases, that means the size is more. So nanoparticles have the lesser or very small, like a thermal properties or melting point is there. About the mechanical properties, so the mechanical property, the copper is having this copper and palladium have this malleable and ductile type of properties. So we can just hit with this certain rods, then it will be converted into like this ductile पत्रे तयार करू शकतो आपण त्याचे, है ना, कॉपर पासून. ओके, सो जर आपण बल्ब घेतलं तर बल्ब लगेचच आपण त्याचं काय करू शकतो, त्याचं आपण एक पत्रा तयार करू शकतो. बट व्हेन वी टेक 5 to 7 नॅनोमीटर्स ऑफ दिस टाइप ऑफ पार्टिकल, त्याचा हार्डनेस हा त्या मेटलचा हार्डनेस 500 टाइम्स वाढतो. 500 टाइम्स म्हणजे वी कॅनॉट इमॅजिन दिस 500 टाइम्स मीन्स लाईक अ very very big number is there. Then electrical conductivity is also increasing. If you have carbon nanotubes, then those can be, carbon nanotubes are generally conductor or semiconductor in the behavior because those are in the nano. For example, तुम्ही जर पाहिलं असेल घरी किंवा आता थंडीमध्ये तुम्ही काय करता, शेकोटी वगैरे जर पेटवली, शेकोटी पेटवली तर जी काय राख तयार होतील त्याला आपण कार्बन म्हणतो, है ना. हा कार्बन जो आहे दॅट इज इन्सुलेटर, टोटल इट इज अन इन्सुलेटर. पण जर त्याला नॅनो फॉर्म मध्ये जर तयार केलं, त्याचे नॅनो ट्यूब्स वगैरे जर केलं, तर ते इन्सुलेटर पासून आपण त्याचं सेमीकंडक्टर किंवा कंडक्टर तयार करू शकतो. आणि conductor and semiconductors are used for the electricity transport. So that's why these are having a very good applications if you convert them into the nanometers. Now all these are properties. What we have seen, what is nanoparticle first, and then there are certain properties. Now, okay, this is okay, but how to synthesize this nanoparticle? Now we are going to see the synthesis. There are two main approaches are there. This type of figures are there on the internet. You can just see these figures are there. So here there is a top and here there is a bottom. Okay, so let us consider there is a building present here. Whenever you want to go up, so this type of an approach is known as a bottom up. You are going from bottom to up, right? And if you are at the top, you have to come to the bottom. So this type of an approach will known as a top down approach. Okay, so two approaches are there, but this is not the exact meaning, only the names are given like a total this type of top down and bottom up approach. Okay, what is its meaning, exact meaning of this? Nanoparticles come here in between this here. Okay, so when we have a bulk material which we can see through our naked eyes, if you put them into the grinding, okay, so the continuous grinding will make a small particle. Grinding means we have a wheat. ओके, सो गहू वगैरे आपण जे गिरणीमध्ये दळतो ते आपल्याला डोळ्याने दिसतात, पण ते पीठ जे आहे त्याचे पार्टिकल जे आहे, सो वी आर मेकिंग इट्स ग्राइंडिंग, राईट, कमी कमी करतो. दॅट टाइप ऑफ अप्रोच इज नोन ॲज अ टॉप डाऊन अप्रोच. बरोबर समजलं तुम्हाला टॉप डाऊन अप्रोच? जर वरतून खाली जे साईज जास्त आहेत कमी कमीकडे जे येतो त्याला काय म्हणतो आपण, टॉप डाऊन अप्रोच. एक दिवस 2 दिवस जर गिरण चालूच जर ठेवली आपण ती गिरणी, तर काय होणार, that will goes to further nanoscale type of an particle. याला जी मेथड आहे, फॉर एक्झाम्पल ए बॉल मिलिंग. सो बॉल्स आर केप्ट इन टू द वन ऑफ द रिएक्टर आणि त्याच्यामध्ये पावडर टाकली जाते. जे बॉल जे असतात ते बॉल्स हे मेटलचे बॉल असतात. ते काय करतात, त्या पार्टिकलला खूप क्रश करतात. त्यामुळे ते काय म्हणतो आपण त्या अप्रोचला टॉप डाऊन अप्रोच. नाउ व्हॉट इज बॉटम अप अप्रोच? For example, we have seen one example here, zinc oxide. So how to synthesize zinc oxide? Zinc oxide is this like an atoms of zinc and oxide, oxygen's atoms are there. We cannot see this nanoparticle. How we are going to see the atoms, right? म्हणून आपण काय करायचं असतं, झिंक ऑक्साईड काय करायचं, ऍटम्स घ्यायचे. पण कसं घेणार आपण ऍटम, हे दिसतात का आपल्याला? नाही. फॉर दॅट पर्पज वी हॅव टू टेक इट सॉल्ट. For example, when you going to synthesize this zinc oxide, you have to take its salt. Let us consider zinc chloride, ZnCl2. When it goes into water, it makes its iron, zinc Zn plus 2 and this Cl2 minus, right? This will be an atom, and when you add NaOH, so zinc will combine with this zinc will combine with the OH, it forms zinc hydroxide, and when you heat it, it will quick hydroxide will convert into oxide. So this is an bottom up approach. Your atoms are combining from a nanoparticle. So this method is like what you are taking, one atom, then one atom, another atom, one other atom, and you are setting them into one another. So that's why there will be a very unique morphology can be created out of this type of approach, that is bottom up approach. That's why this bottom up approach is highly appreciated, or that will have advantages over a top down approach. Okay, म्हणजे काय होणार, तुम्ही ज्यावेळेला बॉटम अप ऍटम्स घेणार, ऍटमचं कसं ऑर्डरली अरेंजमेंट असणार ना, ते एकत्र व्यवस्थित सेटल होणार, व्यवस्थित बसणार. त्यामुळे दिस बॉटम अप अप्रोच इज लाईक त्याला थोडंसं जास्त ऍडव्हान्टेजेस आहे टॉप डाऊन अप्रोच पेक्षा. Okay, so this is the case. Now we are going to see one of the synthesis method, that is a wet chemical synthesis. Wet chemical synthesis, there is a process, sol gel process is there. Wet chemical means what? You have to take a solvent, chemicals, and you have to synthesize it. So you know sol gel. So what is sol and what is gel, that we are going to see here. So the sol gel is very simple, and this procedure is shown by one small diagram over here. Okay, so this is a precursor, means a starting compound is there. So this precursor or starting compound is nothing but a salt, like a zinc chloride that we have seen. What we have to do, we have to take in the powder form, we have to add a solvent. Okay, the solvent is added, we have to stir it. As we are stirring it, there will be a solution is prepared. That solution is known as a sol. Okay, so it is having some particles into the solvent, that is known as a sol. Now that sol, if you heat them or dehydration, water is removed from this, then it will convert into gelish form. थोडंसं चिकट तयार होईल, त्याला काय म्हणायचं, जेल म्हणायचं. दिस जेल, ही जेल जे आहे, तुम्ही डिंक पाहिला असेल, गम, राईट? सो दॅट विल बी लाईक दिस. This is known as a gel. So sol and gel is involved in this process. That's why this process is known as a sol gel process. Then if you have taken this gel, if you rapidly dry it, rapidly dry means you have taken this out from the oven, if you put it into the fridge, there will be aerogel is formed. So aerogel, gel will remain as an gel, but there will be certain air drops form inside this, that is known as an aerogel. Rapid केलं तर drying. If we do a normal type of drying, there will be a zero gel is put. Zero gel means there will be no any type of air gap will remain here. This is highly appreciated if you got a zero gel. मग झिरो जेलला आपण काय करायचं, हीट करायचं क्रुसिबल मध्ये जास्त टेम्परेचरला. जनरली इट इज अ मेड ऑफ अन सिरामिक. त्याला जर आपण कॅल्साइन केलं, हीट केलं, दॅट विल बी कन्वर्टेड इनटू ए सिरामिक पावडर. देन दिस सोल विच वी हॅव टेकन, जर त्याचं स्पिन जर केलं, छोट्या एखाद्या पेन जसं इंक सोडतो तशा प्रकारे जर आपण सोल्युशन सोडलं, त्याला स्पिन केलं, ते विल फॉर्म ए फिल्म. देयर इज अ CVD, chemical vapor deposition, and there are certain type of machineries are there, equipments are there, those are responsible for this thin film coating. मग फिल्म कोटिंग पुढे करायचं तर तुमचे मोबाईल वगैरे जे आहे त्यावरती आपण कोटिंग केलं जातं. इनसाइड कम्प्युटर्स मध्ये थिन फिल्मचं कोटिंग असतं, सोलार सेल. So this type of things can be doing by using this solution. Again, this solution can be kept for longer period. Okay, and if you calcine this solution, that will gives you the powder, and this powder is nothing but in the scale of a nanometer. Okay, so in our college, when there will be such a practicals are there, you can easily synthesize this. So this is the process, and it is known as a sol gel process. So this is just a diagram. When we go for this chemical reaction, this is a salt. Okay, so it is known as a metal alkoxide. So R means, let us consider there will be like a CH3, so it will be like a metal methoxide. Metal is there and OCH3 is there. When you are adding a water, hydrogen is coming here and replacing this R. So ROH, that is alcohol is formed. So alcohol you can evaporate it. You will get this type of an hydroxide, OH hydroxide. When this hydroxide is again comes in contact with the another molecule of metal alkoxide, it will form this metal or this oxygen and metal bond, right? And when you heat it, then there will be such type of a metal oxide is formed. And which is metal? If you have taken zinc over here, zinc and OR, then metal will come here. So what we will get? Zinc and oxide. So this is known as a zinc oxide nanometal. Right? So this is the case. Now there are so many things are there that can be done that can be understood by using this type of inputs. That is gelation. Gelation means formation of a gel. Then aging of gel means you have to just continuously stir it, shake it. That will be like a formation of a solid mass into that gel. Then drying of gel. This generally takes place inside the oven. Okay. And dehydration means if you heat it at a heat 100 degrees Celsius, whatever the water part is there, that can be removed from this. Now, in the precursor is used here, and if you have this powder, what you have to do? Powder मिळाली. Powder म्हणजे काय? हे कसं माहिती करणार? त्याचा आपल्याला काय करावं लागेल? Characterization. So this analytical chemistry person, they are having a very good scope in the industries, in the national institute, international institute. Such type of machineries are there. If you have seen, there are so many machineries are used for the characterization of this nanomaterial. For example, here one table is given. In the table, 5 techniques are given. For example, UV, then X-ray. This is known as a same, that is scanning electron microscope. Then transmission electron microscope. Then IR spectroscopy. What it gives, that is given here. For example, I'll just tell you the cost of this instrument first. UV visible spectroscopy. If you are going to purchase it inside in our college, so like below 30,000 or like 30 to 50,000, we can get this type of UV machinery. Okay, smallest part. It can comes up to the 2 to 3 lakh of this costing is there. When you go for this FTIR, this FTIR requires 10 to 20 lakh rupees or lesser as per the requirement. Okay, 10 to 12 lakh for its purchasing. But now, when you go for the X-ray, so X-rays are involved in the X-ray diffraction type of a spectrometer. So that's why controlling this X-ray, there are so many machineries, different parts are there. Again, it will give the particle size, then the crystal structure, its geometry. So that's why it is a very useful technique, and it can have a cost around 50 to 60 lakhs X-ray. Okay, so this will be very costly. Now, when we go for the same scanning electron microscope, it will give the surface morphology. Means what is the shape of that nanoparticle that you have prepared. Like झेंडूची फुलं पाहिले आपण marigold, such type of morphologies are there. Square, like so many morphologies are there present of this scanning electron microscopy application. So its cost is around like 90 lakhs to 1 crore. Okay, so 90 lakhs of this machineries. And when you go for this TM, it will give you the exact particle size. So this is very important. TM, transmission electron microscopy. So this is very costly. Like certain instruments are like 10 crores having its price. Okay, so this is not available in everywhere. Colleges can have UV, colleges can have this FTIR, even college can have this XRD. But for you have to go into the national institute like NCL, ISER, IITs, ISC. Okay, so those machineries, those are having this type of same and TAME machinery. Those will be very. What is the exact use of this machinery that is shown here? So for this history of this nanotechnology, there was a Richard Feynman in 1959. He gave one statement. What is that statement? That statement is like this: there is a plenty of room present at the bottom. Means what? There is a like so many things can we do if you go to the small size. So this will be like a term as an origin of this nanotechnology. And this before that, Weston and Crick have already proposed this double helical structure of DNA and RNA. So this will be like an invention of this nanotechnology. and that comes again as you are synthesizing different type of technologies, it comes into picture. Okay, so this machinery is here. See the XRD. XRD give you the crystal structure, whether it is a cubic, whether it is a hexagonal, rutile, right? Such type of morphology or such type of crystal structure can be given by XRD. So how this is operate? See, this is the machinery. Here there is a one sample holder is there. Here sample holder. Sample holder is of the size around, like, if you know the coin of 50 paisa, or like a less than 1 rupees coin, size is here. Okay, so that is a sample holder. You have to keep the powder here. Okay, then this there is a gonimeter is there. Gonimeter means it will be like it's a source of an X-ray. Okay, so the X-rays are coming from this to on the sample. Okay, and what is the diffraction of this material to this X-ray is recorded by this detector. Okay, now the X-ray source remain as it is constant, and this can be rotate like this. Okay, and it comes with the 0 angle from 0 to 90. Okay, so this much angle can be measured by using this diffractometer. It can rotate, and 90 angle we have to find. Then by using its Weiss indices, Miller indices, its different planes, we are going to find its particle size. So this XRD is very important. Then there is a same scanning electron microscope. See here, scanning electron microscope is cross section is shown here. Here the sample is kept somewhere here. See, sample is there. Then there is an electron gun is there. So electrons are falling from down side from this gun when you start this machine, and it goes here. So there are so many things are there which control this electrons, and that goes on the sample. Okay, so the sample is pasted on the conducting surface. So electron will come here, electron will make a certain process over here, and when the back scatter electrons are going, those scattering will happen. Here the detectors are there. So these detectors can take these signals and form a image. And that image is nothing but a very small size of image can be recorded, and we can get the morphology of that material. Okay, so that is the scanning electron microscope. This is the image of actual scanning electron microscope. So this is the scanning electron microscope, and we can watch it on the computer directly what is happening here. So there is a sample holder. You can remove this, you can put your sample over here, and here nitrogen is there, so as to make a very less temperature, and electric gun is present over here. So whatever things are happening, we can see this. This room is like a under continuous ACs are there. So see, AC is shown here in window. So there are so many ACs are there so as to make a temperature constant, because there is a electrons are there. So we have to keep this system at the below the room temperature. Otherwise, there will be each and every part of this machine is so costly. That's why this thing is there. Next is a TM, transmission electron microscope. See here, transmission electron microscope, the sample is not kept at the bottom, but the sample is kept here. See, this specimen holder means a sample holder. Sample is here. Okay, and same electric gun is there. So that electric gun, it pulls the electron on the sample. So the depending on the sample, this electrons is transmitted through this sample, and then there are so many lenses are there, those can convert that signals into the image, and there is just one CCD camera is there, we can watch it through directly our eyes. Okay, so the viewing screen is there, we can see what type of image is there with this sample, we can find exact size of that material. One atom can be seen by using transmission electron microscope. One atom, so atom is like a very small as compared to nanoparticle, so that can also be seen by using the TEM machining. This is the TEM. It is like if you see, it is like a space station, and it is like a rocket, so it is very big, require a very huge room for this. So sample holder, sample is placed here, gun is at the top, and we can watch it through this window. So if you remove this blank sheet, there will be a window, glass is there, we have to watch it here. We can maintain, we can capture this here image, and again that is also joined to the computer, that will give you the exact image. There is an UV and FTIR spectroscopy. See the FTIR means it is an Fourier transform IR spectroscopy. So it can give you the functional group. Functional group means what? Whether zinc and oxygen is bonded or not. That can be given by using this type of machinery. That is FTIR. And UV will give the color. Its lambda max can be calculated by using the ultraviolet. In the history of these nanoparticles, there are so many rivers are there in India, or worldwide. There are so many rivers, right? So if you go to your hometown, तुम्ही जर कधी तुमच्या गावाकडे गेला, स्वच्छ पाणी असतं नदीमध्ये खूप, आणि तिथे तुम्ही जर पाहिलं तर खाली त्याचा तळ दिसतो म्हणतो आपण, है ना, ऍट द बॉटम. बट यू कॅन सी देर आर सो मेनी कलर्ड स्टोन्स आर देअर. पूर्वी असं होतं की ग्लास वगैरे तर नाही, पण स्टोन्स असायचे, आणि त्या स्टोन्स मध्ये काय व्हायचं, गोल्ड वगैरे जर असेल तर ते गोल्ड त्यामध्ये दिसायचं. ओके, सो दिस इज एव्हरीथिंग इज मेड अप ऑफ गोल्ड. ओके, सो रुबी रेड कलर इज this is like an god. Okay, for the other countries it is like an god's picture. त्यात काय केलं इथे दिसते तुम्हाला, this is a stones, small stones are there. See, part of the stones are there. All these stones are made up of gold, but because of different size of a nanoparticle, this can be having a different color. त्यावेळेला नॅनो पार्टिकल्स होते का? नाही. बट बिकॉज ऑफ दिस कंटिन्युअस वॉटर वॉशिंग, वॉटर इज कमिंग अँड गोईंग फ्रॉम दिस स्टोन्स और फ्रॉम द गोल्ड, दिस टाइप ऑफ नॅनो पार्टिकल्स आर जनरेटेड. आणि त्या लोकांनी काय केलं, कलेक्टिव्हली मध्ये जमा करायचे, आणि त्याला काय व्हायचं, असा कलर दिसायचा. सो दिस इज अ रुबी रेड कलर टाइप ऑफ एन image from this goddess which they are worshipping in the other countries. Okay, so these are the, like, these are the examples. Okay, so you can search on internet like a number of nanostructure material which we are using in day to day life. Okay, so here again it is an explained that this will be like a 0 dimension, then this will be like 1 dimensional, 2 dimensional, and this cube is like a 3 dimensional thing. So that will be the classification. If the question is there, you can easily show this by using direct a diagram. Now again, this, if you remember that, if you visualize this size effect, the size difference between earth and an apple is equal to the size difference between the atom and an apple. Okay, so the atom is the smallest part here. There are last point is that the applications of this nanomaterial. So nanoparticles or nanomaterials are very important for lighter, like a cleaner, smarter surfaces. Those can be adhere on the glass surfaces. So eyeglasses can be made. Then scratch proof glasses which required to the vehicles, that can be. Then crack resistance painting for on the 4-wheelers, this can be done. म्हणजे काय करतो, जो पेंट देतो तो नॅनो पार्टिकलने जर दिला, त्यावरती स्क्रॅच व्यवस्थित येत नाही, त्यामुळे दॅट विल बी हायली अप्रिशिएटेड. Then RAM, which you are continuously hearing about, the computer can be produced for electronics devices by using nanoparticle. Then there are so many application in water purification. So water purification, silver nanoparticles, we have a in our college also, in our home also, we have water purifiers. If you have seen the inside that water purifier, there is a one rod is there which is made up of generally silver nanoparticles are there, and silver is used for such type of killing bacteria and fungi that can be killed, and it is known as a disinfectant, silver. So that can be. Then self-cleaning materials are there. For example, lotus. So lotus, if you put a water, it will not keep here. So that's why no water means there will be no dust is coming on that type of a plant or the leaves of a lotus plant. कमळ म्हणतो आपण त्याला. कमळ किंवा आळूचं पान यावरती पाणी टाकलं की राहत नाही, तसंच त्यावरती डस्ट वगैरे होत नाही, डस्ट राहत नाही. सो इफ यू प्रिपेअर सच टाइप ऑफ any part of this by using this coating of nanoparticle, it will be termed as a repeller, water repeller, or this type of a dust repeller. Then there are these applications. For that application there are certain advantages. So medical field is having so many applications. As energy sector means energy, this petroleum and diesel, they are increasing, prices are increasing day by day. So that will be very difficult to take this. So for replacement of this, for generation of another energy sources, nanoparticles are important. And whatever the revolution which is happening in the computer and electronics is due to the nanotechnology. Now these are certain advantages. There is only one disadvantage, is that we cannot see the nanoparticles, right? So if nanoparticles are there in the atmosphere, if you inhale them, it will goes inside the body and it will directly goes into the lungs, right? So nanoparticles are so small that they can penetrate this type of in our lungs. So that will be very, very difficult. But as we have seen, so many nanoparticles which we are using are with the good applications, are eco-friendly. So and also we can, if you use a mask during this synthesis procedure in the lab, then there will be no harm will take place to the human body. So this is the nanotechnology part. Hope you have understand this. There is a exercise is given after this chapter. You can solve these chapters questions which are in the multiple choice question. Okay, so based on this topic, there will be question on the various exams, like in the NEET exam, then MHCET exam, the SET exam, GATE exam, NET exam. So that's why this topic is very important. There will be no manipulation in this question. There will be straightforward question will be there. So if you study well for this topic, you will understand these type of questions, and there will be good score. Okay, समज